Welcome to my code walkthrough for multiplayer Dobble with an AI player. I am Lewis Fowler, student number 203232 at GodCol College. So this is a code walkthrough video, so start off at the very top. Firstly, imports, pretty basic here, just Pygame for the display, lots of game stuff. Random, to randomize stuff. Socket and thread, these are all multiplayer, to do multiplayer sending and receiving from the server. And to start off, we have some initialize variables. This is set high, as this is used, the higher this number, the slower the AI is. So this way it's easy to test with a high number if you start like this. Just initializing some variables at the top. So first I'm going to load. This loads up the card, and this can be easily changing the size. This is quite easy, nice to show, but you can change the size of the cards easily here. And so the network class, this is to do with the multiplayer aspect of the game. First off, init, obviously, any class in init. And this one is getting the socket host, so let's get the name of the socket, initializing the server basically. This is making sure you get the correct IP and you get the same correct port. This is giving it the port, and this is combining the server and the port to an address. Connecting. When you connect to the server, it will try and connect to the client, which in this case is going to be the server, and then it's going to return whatever the received data is from that. If it doesn't work, it will just pass straight out. Send. This is an very important one. This is how you send and receive all your data from the server. And what this does is, it will, when you use this send, it will send data to the server encoded in string format of wherever you pass through, and the return value will be what the server returns back, and it decodes it for you. Okay, next I'm loading from a file the symbols. This is from a file for ease and simplification. Then we have the card class. This is one of the most important classes in the whole game, as this is a class that handles everything to do with the card generation and the algorithm that handles that. So it is really a lot of it is the essence here. So got symbols, cards, and lines. So symbols, explanatory, is the symbols on the card. Cards is the number of cards, and lines is when you're outputting it. This is only to do outputting. Generate cards. First, a very important function. Okay, well, we're generating symbols again here for some reason, but it does that. So this is to do with how many cards you can make and how many symbols you need. So the number of cards you can make is equal to this here. So you can see number of cards equals n squared plus n plus 1. So if you want to make a game like Dobble, the original Dobble, there's 8 symbols per card, like this. We want shuffle symbols true as well. Then to find n, we subtract 1 from the number of symbols on a card. So this means in total you can make 57 cards as per the base game. So first up, we're going to add the first set of n plus 1 cards, 8 cards. So we're going to append all of these cards with the first symbol. We then add n plus 1 symbols onto the card, so 8 more symbols. See here. We will then do the n squared, so n sets of n. So this will loop through 2 for loops for the range. And this will append a new card with each one symbol. With one new symbol each. So this is, the symbols are done as numbers here. So for example, 1 might be apple, and 50 would be not banana, but it's alphabetical, so maybe pencil. So they correspond. So here we're making an array of numbers where each one has a value that is unique. So it's kind of hard to explain without showing, but it will mean that each card will end up being in a format like this, where every single number 1, 2, 3, 4, 5, 6, 7 more every single one of these is generated onto a card, like this. But no two cards will ever be the same, so you'll never ever see anything of this site, or even in different orders. So this card is now unique, and only one symbol from this card will be able to match any other card, no matter what. And this is a very, very clever system. Then we shuffle the cards. Pretty simple. We basically just randomize the order. And this is the output. This is currently disabled because it clogs the console. But when testing, this is vital. It simply just outputs the cards in lines. I might be able to show you that. Fine, just run this. Maybe not. We'll see. Oh, yep. And no, I don't think that. This is only output. It's not really necessary. Doesn't really do much. And mostly this is all does for so this whole generate cards returns the cards to the deck. Get symbols, allow symbols to be used later on, return symbols. This, okay, getting one card. So once you have, each player has their deck, you have to get a card from the deck, or hand. So we simply take over between the range of the length of the player deck, which is going to be 27, -1, because index from 0. And it will then pop from this deck the card once it's been played. It's just to do with getting the card in the hand. Then once it's played, you will never get the card again. And the same, very, very similar for the computer player. This is just generate. So this is another. This is when you generate symbols for the cards. So this uses the get one card function. So you pass in player deck, and you use card.getSymbols. So you use these symbols, and it will return the actual cards for your hand. And the deck class, crit hands. So you've got a whole deck, which is the entire deck in its whole, so every single card. The deck length is used for calculations. The computer deck and player deck, which are currently just empty arrays. And then it simply splits the deck in half and randomly deals the cards between the two players. Or not randomly, the first half, second half, because it's already shuffled. So it's like going alternatively almost. And then button. Button is a button class for clicking on buttons, returning buttons, for matching buttons. So you've got to pass in the image, which is just going to be what's displayed, the rect, which is to do with the collisions and when you click on it, and the name, which is crucial for matching the buttons. Get here, so you have get, so when you click on it, it returns that it's been clicked on. This is for something else, but this is for getting clicked. They both. This returns the collide point and where it's been clicked, and this returns true if the button has been clicked. And this get name is used for matching. So when the button is clicked, what it will do is it returns the name of the button, which is then used to match symbols. Then the decks are created with deck.createHands. So you now have a player deck, computer deck. And this is not needed. Okay. Here we go. This is the main Pygame part. So we have Pygame.init. This initializes Pygame, starts the whole thing up. All the process start. Set the resolution. So we use a set a resolution here. 800 by 800 is what I've gone for. Could be more, but on a smaller screen, it's kind of hard to use anything higher. Anything smaller, and you can't really fit much on there. So I think 800 is quite a nice compromise. Res is simply the total res, so it's the res x and the res y. And here we find the center of the x and the center of the y. Now this is used so that if you change the res, the locations of the symbols and cards, although it might be perfect, it should always be passable if they're in. So if I change this to half the size, so too with the center locations half. And since the other parts are using these two, it will mean that it should ideally still be playable with a smaller resolution. So we initialize the screen. So we make a screen and we set the display mode to being the resolution, which is 800 by 100. We initialize a color here, so we're going to use this color quite a lot as white. We make a light shade and a dark shade. This is for buttons. Also, you want to get the width of the screen and the height of the screen. This can change, obviously, so we're using this twice. Then we have two kinds of fonts. Small font, used for buttons, and large font, used for displaying. Then we have different button types with text. So, for example, these will all display on the main menu when you are running it. And then we initialize the symbol lists. So this is where, for the first hand, for the very first start, you want to initialize this. So when you start, the game starts with a hand in each corner. So we load in the symbols from the images. I should probably also show this. So this here is train data, which is in my documentation explained. But basically, this is a folder containing 250 images, which are 57 images, 250 of each image, which are randomly rotated in size to different sizes. So this here is getting a random image for your card, because in real Dobble, on each card, the symbols are all different sizes and different shapes, as well as orientations, to make it harder to match them. So this is partly that. And then it takes from the symbol list the first symbol, second symbol, etc., etc. And again here for the AI. Here's an output. It's going to be hashed out now, but this was obviously all for debugging. I'll keep this for this reason. Here we set start game to false because the game hasn't started yet, and we create the first buttons. Now these buttons are for the player, so the player has to have buttons to press on to be able to match their symbols. And here we have a function called match symbols. It's quite a simple concept really, but basically you pass in the one left symbol that was clicked and all the symbols on the right. And if the name of the left symbol when you match it, so that's what the return name did earlier, when you return the name, if that name matches the name of any of the right symbols, that means, well, that's the only symbol that matches, so therefore it is matched. If that doesn't happen, then there's no match and nothing will happen. So we start off obviously with saying that these aren't matched because they're hard. Then the big main while loop starts. So this is the main Python loop, not Python, Pygame loop, which runs like all of the main menu displaying, starting the game, closing the game, that sort of stuff, all within one loop. So straight away, we just say that no opponents are selected. This is to do with multiplayer online, single player versus AI, or player versus player. And we create the player and computer decks. And also, computer deck is simply a placeholder name almost, as in the deck is just another deck. Computer deck was the name I used originally, and after adding multiplayer, when I was adding multiplayer, I realised the computer deck wasn't a good name, but I simply changed it so that it makes more sense when reading the code that player 2 deck is also the same as the computer deck if you're doing multiplayer. So, when you start on the menu, if start game is true, which is if you've pressed the start game button, it will then check if you have selected online or single player. So all this is doing is this is all to do with visuals, hovering over buttons, highlighting the button, making it go dark when you're on it. And it's basically just checking, are you doing single player or multiplayer? So it's checking, if it's clicking within this area, it's an online game. Clicking with this area, it's a single player game. And then updating the display, obviously. And if this will loop until you choose an option, since it's a Pygame and you have to have something going constantly. If multiplayer is false after this stage, it will then start a single player game. So straight away it will blitz, which is essentially just putting the symbols or the cards or the images or the buttons onto the screen. So in this case we're putting 3 cards on. The player's card, the AI's card and the deck. And this is how we are assigning the symbols on the right hand side. We're giving temp values based on what would have been on the left, and we are putting them onto the right card as if they've been matched for the first time. So we start with the card on the deck. Then we're going to use this subroutine here. So this is going to start again. Not start again, but it's going to remove another symbol, a card from it. And it's going to generate the AI's cards first. Obviously, since AI, there's no buttons for the AI because it's just an AI. It doesn't need to press them. And then for the player, we have buttons here. So this is the same with buttons. And of course, they're not matched. Now, this is when the main actually playing the game. So now it's initialized. The screen's there, you're started. This is when it really begins properly. So first we're having two variables here, which are how many cards both players have left. So players and AI cards. And we're setting the rest random time to be a random number between 0 and AI difficulty. So this is how the AI's speed is decided. If they choose a lower number, so basically there's easy, medium, hard, and hard is the lowest number, medium is medium, easy is the highest number, and that means that if this equals 0, it's like a random way of the AI matching speed to be able to match faster or slower depending on how you select it. So if it's easy, it will match less because there's a much larger range of numbers for it to be. If you have it on hard, it'll match much more often because there's much fewer numbers it can be. In fact, hard is very hard because that's kind of the point, is showing how fast it can be done by the AI. And here, of course, we're checking that if the deck is empty, you can't play the game because that would mean it's over and it should be ended. Here we go. This is when we're displaying the length of how many cards are left for the player. And here we go. So if the AI matches a card, it will say in console, AI is matched. Screen will change, well, same colour as before, but it will refill the screen so it covers everything up before, removes it. And then it will update the amount of cards left for the player and the AI. It will then repeat, and it will place the AI symbols onto the right hand side card and generate new ones for the AI. And of course, afterwards, always set it to false, otherwise it will infinitely loop. It's a very similar process for the player, but this time you're comparing your button click once that's been true. Then this will happen where you have to compare, you take the temp symbols to the left from your hand to the deck and generate new ones for yourself here. And then you make more buttons and you blip the buttons on. It's an extra step for the human doesn't have to worry about. And here we have every single stage of the game, always being able to get out of it with the escape key. So you can always return to the previous screen with escape if you wish to get to the menu again, try something else. You hit single player by accident, hit multiplayer by accident, you can just hit escape, go back. That's on every screen. Okay, here we go. So this is checking if it's been clicked. So this is initializing the match symbols. So if your mouse button goes down, so if you click, it will make a button list out of your buttons. And for the length of the button list, it will compare if you've clicked that button and the game's still running. It will match the symbols and check it matches, else it won't do anything. As that's part of the built-into match symbols, there's nothing needed. And of course, we need to get the position of the mouse so we know where the mouse is. Same here. Now, multiplayer. If you select the multiplayer option, it will set it to true, and straight away we make a network N. Now this is using the initial network class at the very top. And so we'll make, as before, we'll make symbol list and player 2 symbol list. So this is just like we were doing before. Again, note this says generate symbols AI, but it is just generating a second deck. It doesn't necessarily be AI. It's also for player 2. Bitting again, this is simple process, same again. Same as before, so the setup is the same, it's just setting up another screen, but this time the difference is that player 2 can also have buttons, because player 2 can actually play online. So it's going to be 2 players. Okay, quirky thing here is this send first. Do I even need? I don't think I need this anymore. So we have this card buffer here. This is quite important. So for a network to stay active, it must always be sending and receiving data. So this card buffer ensures that before it starts, when the network connects, it is sending and receiving. It makes sure that it still works. It won't close the connection between the server and the player. Okay, one multiplayer is true. So then we connect to the server. This is also obviously quite important. And then we'll send get. And now I will open up the server. I hope this worked. It did not work. I need to change my screen capture to this. So we have here the server. So when it connects, you have a server, and this server has don't even need this stuff. But again, pretty simple stuff mostly at the top, but it gets more complex in the middle part. What you're doing is an IP, so this is simply getting an IP, not manually, using the inbuilt socket function to get the name of the host and simply use that. So if I go college, work, home, it will always work because the IP will change, but it will automatically get the new IP. The port can stay the same as it was. So then we start the server. We use the socket, this here, starting the server. And then we're binding the server to this IP. And then we're also binding it to the port. So 55555. If it doesn't work, it will just cause an exception. It won't work. So then we have the s.listen. s.listen 0 means we can have as many connectors as we want. This I was going to use to show that this could theoretically be used for more than 2 players. If I wanted to do 2, change it to 2, but I'll leave it as 0 because that works fine as well. It'll then also say it's waiting for a connection. So I started. Okay. Do I need X? I believe I need X. Okay, so here we have a global variable cards, and cards is going to be set to a blank string. We then pass, it should be global, but we've put cards in here too. I mean, I think I can remove this. No issue. So maybe this thing called a threaded client. And this takes in the connection. Doesn't need the player, I think. It is passed in the player though down here. Just get the player. So what we'll do straight away is just send a connection saying we have connected. And then the reply will be set to a blank string. And this will run basically infinitely. This just here will run infinitely. What we're doing here. So we're printing. This is for debugging, checking what cards was. That's done. I'll comment that out. So, data. Data is what we're always going to be using as our initial sort of input from the client. So the client thing that gets sent will always be known as data initially. So here we're receiving from the server, from the client, not the server. We're receiving from the client the data. If there is no data, it's not connected, so therefore it'll break and the connection will close. Otherwise, else, it will print received plus the data. So here's where this is used. So we see over here we're sending get. If the data equals get, then it's requested get. And if the cards is nothing, which that means that nothing has been sent yet. So it's just keeping the connection open. It will simply reply with an X, just showing the connection is still open, keeping it running. If the cards are not blank, it will send what the cards are. So here, now let's go back to this screen. If the reply is not nothing, so if the reply is not nothing, then what we will do is we shall fill the screen and we will start by, again, redrawing everything. And we receive the data. So the data is received as a reply and the data is split with this. So to show you this, I've got to show you something else first. So when we're looking at the cards matching, we create an empty string called S. And this is going to have all the symbols from the card, the AI card, player 2's card, and the deck. So what we're doing here is for the length of the symbol list, we're adding the symbol that is in position I, and then we're adding a interrupt. In this case, the straight line. Then we're removing a straight line at the end, so it doesn't cause any errors when splitting. And then we're also adding a bigger split in the form of tilde. And repeating this for all of them. This way, the code, it will come through to this side of the server like this. If you see in the bottom right here, it comes through as this, where there is a split between each word, and then between each like card, you have a bigger split of this, which is a tilde symbol. What this means is, when I receive the data back, I can easily split it and reassign it the correct location. So, here, I'm splitting it between P1, P2, and deck. So P1 is going to be the first 8, P2 second 8, deck third 8. This way we're splitting it so they form their own arrays. Then we're splitting with the straight line. A straight line where basically this will then make player 1 symbols into another array, player 2 symbols into another array, but this time it will be in the correct format. So as it needs to then be re-inputted as another symbol onto the cards. So it will be back in the format I can use after being sent. And then we'll just simply re-update all the symbols for all of them, over the deck, with the player 2, player 1. Don't need this anymore, just testing. And we'll set card buffer equal to reply. Right. Now this is to do with the matching. So this is to do with the matching again. So here we go. If the player, same as before really, but this time it's a bit different in the fact that there's 2 players. So both players can match symbols on their respective cards. So player 1 can match them, player 2 can match them. And this will cause, basically, whichever one matches, it will match that symbol, and then it will match on the other client, it will change it to equal that one. So they're always in real time together. They always see the same thing, multiplayer. Get the match machine again. If the card is matched, we run this here, making sure we connect to the server, we send to the server, and then we print card match with the console, and the same for player 2. And then here we have the winning condition. So this is all the multiplayer handled. This all works, and now we're having the winning. So if the length of the computer deck ever equals 0, it means the AI is 1 because there's no cards left, which means we display computer as 1. And we end the game and go back to the home screen if escape is pressed. Same effect for if the player wins too. Only difference if the player wins is that if you want to record a high score or a score for player. So we'll open a text file called scores. We'll open it in read format because we want to check the current score. So I'll check the previous best. So I'll read the file, and if the previous best is less than the new highest score, that means we want to update the score. So we'll close the file and reopen it in a write format and overwrite the previous score before closing it again. Otherwise, if the previous score is higher, what's the point? It's a higher score, so we just close the file again. The score wasn't high enough. This here is to do with difficulty selection. This is where it handles how hard the AI will play. If it's selected, and while it's selected, this causes the loop to run continuously, so you stay on the window in Pygame. This is to do with highlighting the buttons here, just highlighting them when you hover over them, and it will draw the buttons on here, as well as the texts for them. And now, if you escape again, back to the menu, and if you quit, you quit. But if your mouse is pressed within certain areas, so hard, easy, or medium areas, it will mean that it sets the area difficulty to a certain number. The lower, the harder, the higher, the easier. And this is just handled by the buttons. When you click them, it simply knows and returns the value. And this is to do with accessing the high score now. So when on my menu, high score, again, it simply checks if you've clicked in the correct place. It'll open the score file and it will read out the score. Oh, wait, no, sorry, this is also updating. So if you've somehow quit a game without finishing, it'll update the score as well when you open the high scores. Then if you so this is my menu here. So if you click on the start game button, the game starts. If you click here, you select the difficulty option, which then takes you to another screen where you set difficulties. If you click here, shows you the rules. It will open the rules file and display them. And also, always after you've run it and you've escaped, you set it to false so it doesn't run again. And here's the display high score. This is what I was talking about a second ago. So if you click in the correct place, it will set it to true. The screen will change colour. And while it's true, you open a score file which holds the high scores. You read the score, and then you display the score on the screen. And you blit it onto the middle to let everyone know what your high score is. And the same as before, you can always escape from any of these with the escape key. This is all for the main menu buttons. All this that is doing is simply changing the colours, making it more aesthetic. So show when you're hovering over a symbol, if it's highlighted or not. So that is my code walkthrough. I will now just do a very quick, not testing, but I'll just run it and show you sort of a little bit of a, so you see to do with the highlighting, makes a little more sense. When you start the game, the initialization, difficulty options, highlighting them obviously. You can create, view the rules, see your high score, and you play online too. You need 2 windows for that, but there you go. Well, that's my code walkthrough, and I'll log my testing as well soon. Thank you.